Okay. Can everybody see the board? Daniel, if it's too loud in here, you can sneak out in the hallway. Okay. Okay. So today we're simplifying radicals and we're going to find the discriminant. The discriminant is the everything that goes underneath the square root symbol in the quadratic formula. Some of you learned the quadratic formula last year. I know that I introduced it to my Math 1 kids, but we didn't use it at all. So the first thing that you have to do is make sure when you're going to find the discriminant, you have to make sure that you're written in standard form. So this has to happen first. So it must be, I'm going to put STD form. That has to happen first for you to use the discriminant. The discriminant actually tells you how many solutions your quadratic should have. Today, we're just going to worry about finding the discriminant and simplifying radicals, okay? Today, we're just going to focus on finding the discriminant and simplifying radicals. So again, first thing that we want to do is make sure that we are written in standard form. So our first equation, r squared plus 5r plus 2 equals 0. Well, the first thing I'm going to do is label A, B, and C. Let's figure out what those are. So is this in standard form? Yes, it is. What's the value of A and B and C? So if I want to find the discriminant, B squared minus 4 times A times C, I'm just going to plug these values in. So B squared, well, B is 5. So I have 5 squared minus 4 times the value of A is 1 times the value of C is 2. And then I'm going to simplify. 5 squared is 25. 4 times 1 is 4 times 2 is 8. 25 minus 8 is 17. So the value of the discriminant is 17. Questions about that? Okay, I'm going to slide over to C. I'm going to slide over to example C. Is this written in standard form? Yeah? AX squared plus BX plus C equals 0? No, what do I have to do? Yeah, I have to subtract 8n from both sides. So when I do that, I have negative 7n squared plus 8n equals 0. What does A equal? What does B equal? And what does C equal? Quali, what's A? Yeah, negative 7. 8 and T. What is B? 8. Laura, what is C? Is there a C value? No, so that means C is what? Yeah, C is 0. Okay, so we're finding the discriminant. B squared, well, that's 8 squared minus 4 times negative 7 times 0. Well, 8 squared is 64. Negative 4 times negative 7 is a positive 28 times 0 is just 0, right? So the value of the discriminant is, it's 64 plus 0. So it's just 64. It's just 64. Let's look at example B. Is this in standard form? No, what do you want to do? Haley says we're going to add 7x to both sides. And I think you said we're going to add 9 as well, right? Okay. So that gives us equals 0 on the right. I have negative 6x squared. That 7x is my only x term. So plus 7x. A negative 6 and a positive 9 give me a positive 3. So let's see. A equals what, Jacob? What is the value of A? Help him out, Jose. Jose A, please. What's the value of A? Perfect. What's the value of B? Zach. Thank you, sir. And what's the value of C, Toby? Perfect. So B squared minus 4AC. So I have negative 6, the quantity squared, minus 4 times, oops, that's not negative 6, is it? What is the value of B? 7. Yeah, sorry about that. 7 squared minus 4 times A, which is negative 6, times C, which is 3. So 7 squared is 49. 2 negatives multiplied together give me a positive. Let's see. 4 times 6 is 24 times 3 is 72. So when I add those two together, I think I get 121. Could you guys put all this in a calculator at one time? Yeah, you could. Okay. Example D. The formula that we use is B squared minus 4 times A times C equality. That's how you find the discriminant. Okay. Does that make sense? It's just the formula that we're using. All right. Who feels like they can put D in standard form all by themselves? Feels like they could talk me through all the steps. What do you think, Destiny? You feel like you could do it? Yeah, you want to do that? Thank you. So 4x squared plus 8x plus 4 equals 0. Okay. What did you get for A, ma'am? And B? And C? Perfect. Caleb, do you feel like you could tell us how to find the discriminant? You do not? You don't feel like you could use this formula B squared minus 4AC and tell me what numbers to write down? Okay, I think you could. What is the value of B? So 8 squared. Perfect. So let's see. 8 squared is 64. And 4 times 4 times 4 is? So what's the value of the discriminant? 0. Okay. I'm going to make one up. Just going to make up a quadratic function. And I want you guys to put that in standard form. Put it in standard form and find the value of the discriminant. Sorry. I was thinking about it. It's 3x squared minus 2x plus 7 equals x minus 9. 3x squared. I'm sorry, you guys. I'm doing the best I can today. 3x squared minus 2x plus 7 equals x minus 9. I want you to put it in standard form and find the value of the discriminant. Everyone should be able to do that. God bless you. Use a calculator if you want to. I just made that problem up. Jacob, are you doing this problem? Because it's not in our notes. I want you to do the problem that I have on the board. I want to make sure that you know what's going on. Toby, what'd you get for the discriminant value? You don't know? Okay, I'll give you another minute. Kara, did you figure it out yet? No? Aiden R, what'd you get? I didn't hear you. What'd you say? You haven't done it yet? What is it in standard form? Guys and gals, this is your homework time. What is this in standard form? What do I do to put this in standard form? Subtract the x and, so when I do that, what do I get? Yeah, 3x squared minus 3x plus 16. So plug those values, A, B, and C, into the discriminant, that b squared minus 4ac. Use a calculator and tell me what you get. This is just plug and chug. This is just plugging numbers into a calculator. Jose, what'd you get? Jose M. Did you finish your test? Can you just leave your test on your desk? Can you get me something to write with? Because I can't write with this. Anyone get the value of the discriminant? Who wants to share? Who wants to share their answer? What'd you get, Charlie? You got negative 67. That is not what I got. I got negative 183. Did anybody else get that? Vanessa and Haley? Got it. Look at my work. A is 3. B is negative 3. C is 16. Negative 3, the quantity squared is 9. 4 times 3 times 16 is 192. 9 minus 192 is negative 183. You guys, all you're doing is picking the values and plugging them in. Okay. All right. Now let's talk about simplified radical form. Simplest radical form. So you cannot have anything under the radical that has a perfect square in it. So when we see the word radicand, that's the stuff under the radical. Okay. You cannot have a fraction in a radical, meaning you got to simplify it. And you cannot have radicals that appear in the denominator. Okay. So we're going to start off slow, and your times table is going to be helpful. Your times table is going to be helpful. I asked you guys to like identify that whole diagonal in your times table. What did we say that diagonal represented? The diagonal on your times table, what's that represent? Yeah, perfect squares. Those are called perfect squares, right? So simplifying square roots. You want to break it into two factors where one of them is a perfect square. You take the root of the perfect square out of the radical sign and you leave the other, the not perfect square, in the radical sign. Okay? Those are the steps. I think that we just need to practice. So I'm going to tell you how I always think about this. I'm going to write myself a little note up here that says, can you divide by, and then I just list my perfect squares. Let's see. 2 squared is 4. 3 squared is 9. 4 squared is 16. 25. 36. ... Okay. So we're going to look at each number. Our first example is the square root of 180. So I know that 180 is divisible by 5. How do I know that? Because it ends in a 0. Any number that ends in a 0 is divisible by 5, right? So I know that I could take 180 and divide it by 5. Who has a calculator? What is 180 divided by 5? It's 36. Now I knew that before I set you guys up. I knew that. 36 is a perfect square. 36 is a perfect square. What is the square root of 36? It's 6. So when I simplify this, this becomes 6 times the square root of 5. But what if I didn't know that it had the perfect square, like contained the perfect square of 36 in it? Well, remember the note that I wrote up there. Can you take 180 and divide it by 4? What is it? What is 180 divided by 4? 45. Okay. So I know 4 is a perfect square. That's 2. What about the square root of 45? Is it divisible by 4? No, because it's not even. So let's look at our next perfect square. What's the next perfect square after 4? Let's see. 2 times 2 is 4. What's the next perfect square? 3 times 3 is what? Is 45 divisible by 9? Yeah. 45 is the same thing as the square root of 9 times the square root of 5. But what is the square root of 9? What number did I multiply together? Not 9 squared, the square root of. It's 3, right? And what is 2 times 3? So I get 6 root 5. So even if I have to do this the long way, I'm still going to get the same answer. I'm still going to get the same answer. So we're trying to divide by perfect squares. You're trying to take the number that's in the radical and divide it by the numbers on the diagonal, the perfect squares. So let's see. Is 125 divisible by 4? No, it's not. Is it divisible by 9? No, it's not. Let's see. That's 3 times 3. What's 4 times 4? 16. Is it divisible by 16? No, it's not. What's 5 times 5? Is 125 divisible by 25? Yeah, what is that? So 125 is the same thing. The square root of 125 is the same thing as the square root of 25 times the square root of 5. We're just rewriting this as a product, okay? But what is the square root of 25? It's 5. So this becomes 5 times the square root of 5. Okay? Let's look at the next one. 3,200. Okay. So anytime something ends in 2 zeros, that means it's divisible by what? Yeah, but it's divisible by something much bigger than 5. 100. It has 2 zeros. So this is the same thing as dividing by 100. What is 3,200 divided by 100? I heard someone say it. It's 32. Isn't 100 a perfect square? Yeah. What is the square root of 100? 10. Okay. Let's see if we can break up 32. Is it divisible by 4? Yeah, it is. What is it? The square root of 4 times the square root of 8. But what is the square root of 4? It's 2. So now I have 10 times 2 times the square root of 8. Let's start with the square root of 8. Is that divisible by 4? It is. The square root of 8 is the same thing as the square root of 4 times the square root of 2. And 10 times 2 is 20. But what is the square root of 4? So I have 20 times 2 times the square root of 2. And what is 20 times 2? 40. Dakota, did you just leave your test on your desk? Thank you, sir. Hey, I gave you your filled out notes. I hope you feel better. Yeah, give me a pass. Now that's the long way. That's the long way. Okay. So did you guys notice that 32 is divisible by 16? Do you guys see that 32 is, will you give me one of those ink pens or markers or whatever? 32 is the same thing as 16 times 2, right? So when we got this, after we got this 100, we could have broken 32 up into the square root of 16 times the square root of 2. I want to show you that. Will you put it on my table right there, bud? Say that again. Okay. 152. Here you go, Daniel. So I just want to show you that if you know your perfect squares, you could have right here said 3,200 is the same thing as the square root of 100 times the square root of 16 times the square root of 2. The square root of 100 is 10. The square root of 16 is 4 times the square root of 2. And you would have gotten your 40 root 2. Okay. But you can always just divide by 4 and keep breaking it up. It's going to take you a little bit more time, but you can always just divide by 4. But if something is divisible by 4, shouldn't you see if maybe it's also divisible by 16? I would, right? Especially if it's a really big number. Okay. So those first 3 examples are how to simplify the radical. We cannot leave a perfect square underneath the radical symbol. Okay. Now we also said no fractions. No fractions underneath the radical. So the cool thing about radicals is not only can they be broken up into products of 2 numbers, but they can also be broken up as a quotient. This is the same thing as the square root of 4 over the square root of 25. But what is the square root of 4? 2. And what is the square root of 25? 5. Okay. The other thing that you can think of, the other thing that you can actually think of is you can try to reduce inside the fraction. You can try to reduce inside the fraction. What do I mean by that? What is 98 divided by 8? Calculator dude. Is 98 divisible by 8? But is 98 and 8 divisible by 4? It is. What is 98 divided by 4? Oh, so it's not divisible by 4. What's 98? But they're both even. Are they divisible by what? If they're both even, they're divisible by what? 2. What if we divide this by 2? Oh my gosh, that becomes 49 over 4. I just simplified the fraction. And that's the same thing as the square root of 49 over the square root of 4. Go ahead, Quali. Yeah, 7 over 2. Good job. Okay. So use what you know about fractions. Use what you know about fractions. You can simplify fractions, right? What about this fraction? What if I wanted, Dylan, pick your head up. What if I wanted to find a common denominator? How could I change that 5 to get a perfect square? Like, what's a perfect square that's divisible by 5? Perfect square. Like, what's 5 times 5? So I know that if I were to multiply both the top and the bottom by 5, I'm not changing the value of the number. I'm just changing the way it looks. That becomes the square root of 5 over the square root of 25. And what is the square root of 5? Well, we don't know. It's the square root of 5. But what is the square root of 25? So now we don't have a fraction and we don't have a radical sign in the denominator. Okay. So that's our next big criteria. You can never, ever, ever leave a radical sign in the denominator. It's just mathematically gross. And to get the radical out of the denominator, we do what we call rationalize. So to rationalize the denominator, you multiply by the radical in the denominator. So let's look at our first example. What is the radical sign in the denominator? What's the value of the radical in the denominator? What is this? What does that say? Guys, what is that number? It's the square root of 3. So if I multiply both the numerator and the denominator by the square root of 3, what is this fraction right here? What does this fraction reduce to? Yeah, this is just a fancy 1. This is just a fancy 1. That's all it is. So I'm not changing the value. I'm not changing the value of the fraction. We multiply fractions straight across. So what is 1 times the square root of 3? Well, it's the square root of 3. What is the square root of 3 times the square root of 3? Well, the square root of 3 times the square root of 3 is the square root of 9, because we just break it up as a product. And what is the square root of 9? Say it again. It's 3. So hopefully you see that when you multiply a radical by itself, what happens to the square root symbol? It disappears. It disappears. When you take a square root and multiply it by itself, that square root symbol disappears. Okay? So let's try that again. So we have to multiply this by whatever the square root symbol in the denominator is. So 4 over the square root of 2. What am I multiplying both the numerator and the denominator by? What? The square root of 2, right? Because I need to make that magically disappear. So 4 times the square root of 2 is 4 times the square root of 2. But the square root of 2 times the square root of 2 is, well, it's the square root of 4, yes. But what is the square root of 4? It's 2. And remember we said if you take a square root and multiply it by itself, really the radical symbol just evaporates, right? Can you reduce 4 over 2? Yeah, you can. This will go in, 2 will go into here 1 time, 2 will go into here 2 times. So this actually equals 2 square root of 2. You don't have to do this step right here. I want you to know that if you take the square root of 2 times the square root of 2, it's just going to equal 2. I want you to know that. Okay. Let's try the next one. What's the value of the denominator? The square root of 3. So that's what we're going to multiply by. We're going to multiply both the numerator and the denominator by the square root of 3. This is just a fancy one. The square root of 3 over the square root of 3 is 1. This is just a fancy one. Okay. Let's see. 2 times the square root of 3 is 2 root 3. The square root of 3 times the square root of 3 is it's the square root of 9. But what is the square root of 9? 3. Remember, a square root multiplied by itself is just that number without the square root. They cancel each other out. They cancel each other out. Okay. Jose, how are your notes going, Jose A? Because it doesn't look like you're doing your notes. It looks like you're doing something on your computer. Okay, just checking. Okay, let's do this next one together. 8 over the square root of 2. What am I going to multiply both by? Yeah, I'm multiplying the numerator and the denominator both by the square root of 2. So the numerator becomes 8 times the, and the square root of 2 times the square root of 2 is just a 2. Can you reduce that? Yeah. What is 8 divided by 2? So this becomes 4 root 2. What about this next one? What did we do up top when we had a fraction? What did we do first? We rewrote it as a radical over a radical. So what am I putting in the numerator? 20. And what am I putting in the denominator? Okay. Let's see. Can we break up 20? Is there a perfect square that lives inside of 20? Like, is it divisible by 4? Is it divisible by 9? Is it divisible by 16? Is it divisible by 25? What's it divisible by? So the square root of 20 is the same thing as the square root of 4 times the square root of 5 over the square root of 7. But what is the square root of 4? 2. So this is 2 times the square root of 5 over the square root of 7. Can I leave the square root of 7 in the denominator? Yeah? No, it's not allowed. We can't have a square root in the denominator. It's mathematically gross. It's not allowed. So we multiply by whatever the square root is in the denominator. And it's 7. We just multiply by the square root of 7 over the square root of 7. That's just a fancy 1, right? So the whole number 2 stays the same, but the square root of 5 times the square root of 7, those are both square roots, so we multiply those two together. 5 times 7 is 35. And the square root of 7 times the square root of 7 becomes just a 7. Okay. What about this next one? Take a look at your times table and find 108 on your times table and see if there are any large perfect squares that multiply together to equal 108. No? What about, so what's one factor of 108? 9, yeah. It's the same thing as 9 times what? Okay. What is the square root of 9? 3. So now I have -2 times 3 times the square root of 12. Does that make sense, what I've done? Okay. What is -2 times 3? All right, perfect. So I have -6 times the square root of 12. What are some factors of 12? Are there any perfect square factors of 12? What? Yeah. So the square root of 12 is the same thing as the square root of 4 times the square root of 3. And I still have that -6 out front. What is the square root of 4? So I have -6 times 2 times the square root of 3. But what is -6 times 2? It's -12. Square root of 3. All right. 108 is divisible by 36. If you guys saw that, I don't know if any of you did. If any of you tried dividing it by 36. Okay. So your homework is actually the next like 3 pages. But I want to tell you what you have. You have all of it on one page. It says practice 211. But then I went in, I looked at that, and I thought I pulled it out of your packet. I went back into CUDA software and I spread it out because otherwise you can't show any work. So 211, you have 2 practice 211s. The second one is just all spread out. It's the problems all spread out. Let me show you.